Before we begin, I will say that I will pick up the pace. At this point, we have done flip simulations, we have created white water, and we have also created ocean surfaces with the ocean spectrum. And since we have created most of these exercises from scratch, I'm pretty sure that the workflow I will use for this final exercise will seem even easier than before, since for most of the part I will be using the shelf tools. Being that said, what I'm going to do first is create the collision geometry that we will use for practically all our simulations, then create our main flip simulation. After that, I will create the white water, and finally I will create the snow avalanche falling from the mountain. So let's get to it. I will hide for a moment this geometry. At this point, I will also save my file with a different version. And here under my helpers backdrop, I will create a new geometry node. I will call this node Terrain Collisions. And here I will merge in this terrain, so we can copy this out node with Ctrl+C, go back to our terrain collision geometry, and add an object merge node. I will change its color. I will also change its name to merge terrain. And now under object 1, I will paste the path that we just copied to bring in the terrain geometry. Now, one thing I don't want to do is to use the entire geometry as a collider, since the effect will be more or less localized around this corner. So I will create a cutout of only the area that we will be using. So first things first, if you take a look beneath the terrain, this is an open geometry and this won't do. So what I'm going to do is I'm going to create an extrude volume node. This will help me create some depth to this object. So now if you take a look down here and we increase the depth, say to 12 meters, you will notice how we have a platform and it is no longer empty. We have a solid terrain. Okay, so another thing that I'm going to do is I will create a box and I will use this box to boolean out only the part that we need. So I will connect the terrain to the first input, the box to the second input, and now I will create a larger box. I will input some values that I already had calculated. So I will use the X size of 104 meters. I will use 57 meters in Y and 95 meters in Z. As for the center position, I will use 20 meters in X, 16 meters in Y, and 12.5 meters in Z. So now if I display my terrain and template the box, you will notice the area that I will use as a cutout for our collision geometry. So let's now click on the Boolean node. Let's check its parameters. So by default, we're subtracting A minus B. So instead, we need to intersect these two operands. And this is exactly what we need. So now what we will do as usual is to lay down a collision source node. We will connect this to the Boolean node. And I will change the volume's resolution to 0.8. I will also add two nulls. One I will connect to the left output. Remember, the left output is the actual geometry. The right output is the volume. So this one I will call out collision geo. I will alt and drag to click this node and connect it to the second output. And I will call this one out collision volume. And this one is the actual SDF. Okay, so I think we're ready with the terrain collision. Now let's create another geometry node. This one will be for the building collision. So let's call this one building collisions. In this case, we will bring in the collapsing part of the building. So let's dive into the node and look for this null called out building destruction. So this output is only the part that is collapsing from the building. So I will copy this node, Control C, go back to my building collisions node, and again I will build an object merge, change its name, and call this one merge building. Now I will Control C under object 1 parameter to bring in this geometry. Of course, this geometry is animated. Again, I will lay down a collision source. This time I will use a higher resolution volume, so I will go with a default of 0.1. As usual, I will create my output nulls. The first one will be called out collision geo. Let's change the color to black. Let's Alt and drag to copy it, connect it to the second input, and call it out collision volume, just as we did with the terrain. Now here I will do something different. In case of the terrain, we have a static mesh that only has to be calculated one frame. With the building, we have an animated collision that can take a while to cook every single frame. Actually, if you try to play this animation, it will take some time to go frame by frame. And this is something that I want to avoid. And the way we can optimize this is by caching this volume and reading it back whenever we want to use it. So let's do that now. I will drag this null downwards. In fact, I will disconnect it altogether. And I will lay down a ROP geometry node, connect it to the second output of my collision source, and I will change the name of this node to building collision volume. I will change the valid frame range to render frame range. And as usual, I will save this file in the geometry folder, in a folder with the name of our node. So I will use the $OS variable as usual. And the file will have the variable $OS as well, with the frame padding of 4. And of course, it will be a BGO. So that's it. I'm going to cache the files to disk. I will also add a file node. And I will channel reference the output of this geometry node. I will right click and copy the parameter. Channel reference to the geometry file of the file node. So paste relative reference. Let's change the color of this node, connect it to my null. And again, let me cache these files and I will be back with you soon.